warahmatullahi wabarakatuh, and hi everyone. In this video, we are going to look at the solution for DM025 Program Set 6. So let's take a look at section A. So in this section, consists of 3 questions. Answer all questions. So 1A, given that fx is equal to 2 over x plus x, by using the first principle, find f prime x. The formula for first principle is f prime x equals to limit h approaches 0, 1 over h times fx plus h minus fx. So now you need to find fx plus h. So fx plus h is 2 over x plus h plus with x plus h minus fx here. Okay, so that is your first mark, K1. And then you simplify this fraction. So this is over 1. Okay, so you cross multiply. You will get 2 plus x plus h square over x plus h minus 2 plus x square over x. Okay, now another marks, okay, comes whereby you cross multiply between these two fractions. So here you will get x multiply with 2 plus x square. You expand this quadratic, x square plus 2 xh plus h square minus 2 plus x square times x plus h over the denominator is x times x plus h. So this is another K1. Okay. And then next you simplify. You simplify your fraction here. Okay, you will get another K1. So expand, multiply x inside the bracket and then expand this to bracket here. Okay, and then you get 2x plus x cubed plus 2x square h plus xh square minus in bracket 2x plus 2h plus x cubed plus x square h. And then we can see from here you can simplify 2x and minus 2x, x cubed minus x cubed, and the rest is stay as the same. Okay, and then now you are left with a function. From here you are left with function 2x square h plus xh square minus x square h. Okay, now each term has h, okay, in it. So we can factor out h to simplify with 1 over h outside the bracket here. So you factor out h from this expression. So you get 2x square plus xh minus x square. Oh, sorry, you have minus 2h here. Minus 2h. Minus 2. Okay, and then after you simplify the function, okay, 2x square minus x square, you get x square. So x square plus xh minus 2 over x plus h. So as h approaches 0, this becomes 0, this one becomes 0. Okay, so you will get your answer x square minus 2 over x square. Okay, so another K1 is you evaluate the value h, limit h approaches 0, and then final answer J1. Okay, 1 minus 2 over x square. So here actually you can simplify x square divided by x square minus 2 over x square. So here you become 1, this one negative 1 over x square. Okay, so next for question B. Question B, they want to differentiate y with respect to x. Okay, so this is our function. Y equals to 1 over 1 over cube root of x plus square root x. Okay, so first you need to change into index form ataupun indices. Okay, so x power of negative 1 over 3. Why negative? Because this value is on the denominator, so you need to bring to the numerator, so you have negative sign here. Okay, plus x power of 1 over 2. And then you differentiate. Okay, divide the x, differentiate, so negative 1 over 3 power bring to the front, so negative 1 over 3 times x power of negative 1 over 3 minus 1, you get negative 4 over 3. Same as this one, power bring to the front, 1 over 2 times x power of negative 1 over 2, since 1 over 2 minus 1 is negative 1 over 2. Okay, so you change, you get k1, and then you differentiate another marks k1, and then you just simplify your answer, you get J1. Okay, so total mark is 8 marks. Alright, so that is question 1 for section A. Next, we look at question 2. Okay, given that your fx is 5x over 2 plus x square plus 1, they want you to find the integration of fx dx and also evaluate the value of Rx from negative 2 to 2. Okay, where fx R is function fx when x greater than equal to 1, and then this quadratic function is if x is less than 1. Okay, so we look at question 2a first, to integrate this fx function. Okay, so as you can see here, our function is 5x over 2 plus x square plus 1. So here we split 1 as a different integral. Okay, so you integrate 5x over 2 plus x square dx plus integrate 1 dx. Okay, now to solve the first integral, you can use substitution. Okay, so let u be your quadratic here, so u equals to 2 plus x square, so your du dx is 2x, so your dx, rearrange your function to get dx is du over 2x, and then okay, substitute this into the formula, so here you will get 5x over u square multiply with dx here is du over 2x. So here 5 over 2 you bring outside, it is a constant, x and x simplify, so you get 1 over u square du. Plus x comes from here, integrate 1, you get x plus c. Okay, now integrate 1 over u square, okay, you will get negative 1 over u plus x plus c, and then substitute back your u here is 2 plus x square, okay, and then you multiply your constant inside the bracket, you get 5 over negative 5 over 2 times 2 plus x square plus x plus c. Okay, so your first mark here when you use your when you split into two integrals, okay, and then you find u and du, another mark, okay, and then you integrate in terms of u, k1, okay, integrate u, another k1, and then final answer j1. Right? Okay, that is for question 2a. Now, for question 2b, as mentioned before, they give you function Rx in terms of piecewise function here. Okay, so fx for x greater than equals to 1 and less than 1. They want you to integrate from negative 2 to 2. So you need to split this function into two functions. So from negative 2 to 1, okay, function that we need to use for less than 1 value here. So x less than 1, this is the function 3x squared minus x plus 1 dx. And then you plus with, okay, continue from 1 to 2. So for value x greater than equals to 1, your function is fx. So fx is here 5x over 2 plus x square plus 1 dx. Okay, so this is your integral here. Okay, we split into two integral. Okay, now this function, we need to solve this function. We already find this value, so you just can directly substitute the value here, okay, to the second term. So you need to find the integration of the first term here. Okay, so here, okay, integrate from -2 to 1, 3s squared minus x plus 1. Integrate 3s squared, you get 3s cubed over 3 minus x squared over 2 plus x dx. Evaluate from -2 to 1 plus your fx here, you already know -5. Just copy back this answer. 5 over 2 plus 5 over 2 times 2 plus x squared plus x. Evaluate from 1 to 2. Okay, so this is K1, 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 4 marks there. And then another K1, you substitute the upper and lower limit into the function, you solve, and then you get your answer, 14, 11 over 12. So total mark is 11 marks. Okay, alright, so that is for question 2b. So next we look at question 3. Okay, figure 1 shows, okay, this is your figure 1. Figure 1 shows the curve y equals to 1 over x for x less than 0. Okay, with the shaded region, given the volume of the revolution is pi over 3 unit cube. Okay, so your volume here is pi over 3. When the shaded region bounded by the line x equals to k and line x equals to 1 is rotated through 180 degree about the x-axis. Okay, about the x-axis. They want you to find the value of k. Okay, we have 6 marks here. Right? Okay, so formula to find volume is V equals to pi integrate outer square minus inner square dx. Okay, but now since it's rotated through 180, so your formula will become pi over 2. And then your outer square function is this function, okay, 1 over, so your formula here will become volume is pi over 2 times integration from, your lower limit must be the lower value, which is k. Don't write -1 to k. Okay, you need to write from k to -1 since k is the smaller value. So from k to -1, your outer function is 1 over x squared. Inner function is x-axis, so -0 here. But if you don't write, it is okay. Okay, respect to x. Because you need to rotate about the x-axis, so differentiate with respect to x. Okay. So next, okay, if you can see from the answer scheme here, this volume you equate with pi over 3 because it is given in the question that the volume is pi over 3 because you need to find k. So the first mark is whereby you write down the first equation, okay, equate with pi over 3, and then the second mark is you simplify 1 over x squared is equivalent to 1 over x squared. Okay, 1 over x bracket square equals to 1 over x squared. And then you integrate 1 over x squared, you get -1 over x. Evaluate from k to -1. Okay, this is k1. Another k1, you subtract upper limit minus lower limit. Okay, and then bring pi over 2 to the right hand side. Okay, for you to easier to solve. And then this pi you can simplify. Alright, so the right hand side you get 2 over 3. On the left hand side, you get 1 plus 1 over k. Okay, so solve for k, another 1 mark. Okay, final answer k equals to 3. So total is 6 marks. Okay, so that's how you find the constant k by using the given information here. Alright, so that is for question 3, section A. Now we move on to the next section, which is section B. It's contribute 75 marks. This section consists of 7 questions, answer all questions. So we look at the first question, 1A. Okay, 1A you have 1a Roman, 2a Roman, and 3a Roman. So find the derivative for each of the following. So we have three functions here, all y in terms of x. Okay, we look at 1a1 first. How to find derivative for 1a1? Okay, so for 1a1, they give you this function, e power of y equals to square root x times 1 minus x over 1 plus x. Now, since we have e on left hand side, so you need to ln both sides, okay, to get y on the left hand side here. Okay, as you can see, we ln both sides, and then you change z into power 1 over 2 here, okay, so that you can bring 1 over 2 to the front by using the law of logarithm properties. Okay, so left hand side, you are left with y. Right hand side, it become 1 over 2 ln x times 1 minus x over 1 plus x. Okay, then by using, okay, law of logarithm, this is multiply, this is divide. So ln x times ln 1 minus x minus 1 plus x. Okay, law of logarithm. Law of logarithm. Okay, multiply become plus, divide become minus. Okay, next, now you can differentiate this function. So dy over dx equals to 1 over 2. Differentiate ln x, you get 1 over x. Differentiate ln 1 minus x, you get 1 over 1 minus x times negative 1. Why negative 1? Because you have 1 minus x inside the bracket. Okay, you have constant negative 1 in front of x. Okay, and then minus 1 over 1 plus x. Okay, so there is 3 marks. So B1 when you're using the law of logarithm, K1 when you apply the law of log, and then G1 the final answer. Okay, so that is 1a1. Next, 1a2. This is your function. We have 5 marks here. So, question 1a2. The function here, y equals to ln bracket x over 5 plus square root x squared plus 4 over 5. Now, since we have the same denominator, we can combine this fraction. So, you get x plus square root x squared plus 4 over 5. Okay, then by using law of logarithm, since this is divide, okay, so you can split into two functions. So ln x plus square root x squared plus 4 minus ln 5. So this is the first mark. Okay, this is y. Now differentiate this function. dy over dx equals to, differentiate ln, so 1 over fraction, so 1 over your bracket here, 1 over x plus square root x squared plus 4 times, you differentiate inside the bracket, okay, minus 0. Since you differentiate constant, you will get 0. So this is the second mark. And then you need to differentiate this thing, x plus square root x squared plus 4. Okay, so here you differentiate x, you get 1. Okay, you differentiate, this is actually, you can change into index form, x squared plus 4 power of 1 over 2, bring 1 over 2 to the front, copy back your function, x squared plus 4 power of negative 1 over 2, because 1 over 2 minus 1, you get negative 1 over 2, and then you need to multiply again with the function inside the bracket here. So d dx x squared plus 4. Okay, and then differentiate x squared plus 4. So here, okay, so here, okay, you can see that you need to differentiate inside the bracket. So on the numerator, okay, so if I factor out this fraction here, so 1 over x plus square root x squared plus 4 to make things more easier, and then multiply with, this one is 1 plus 1 over 2 x squared plus 4 power of negative 1 over 2 times with differentiate x squared, you get 2x plus 4, this one is 0. Okay, and then you simplify, so here you will get, copy back the front fraction, so here you will get 1 plus, since this is negative, so 1 over 2 times square root x squared plus 4 times 2, so means times 2x, means I can multiply 2x on the numerator. Okay, and then simplify 2 here, you get this function. Okay, same as this function here, this step here. Okay, this one is same as this one, 1 over x plus square root x squared plus 4 times 1 plus x over square root x squared plus 4. This is your k1, another k1. Okay, just factor out this denominator to the outside, so we get 1 over. And then this fraction, if you can see here, this is 1, so 1 over 1. We need to cross multiply to simplify this fraction. So cross multiply, you will get square root x squared plus 4 plus x over square root x squared plus 4. Okay, you cross multiply, you get k1, and then simplify this term, you get 1 over square root x squared plus 4. So that is your final mark. Okay, so that is the answer for question 1A 2 Roman. Okay, next for question 1A 3 Roman, they want you to solve y equals to sine 3x over 1 minus cos 3x. Okay, so y equals to sine 3x over 1 minus cos 3x. So here you need to use quotient rule, u over v. So quotient rule, the formula is vu prime minus uv prime over v squared. So here is your u, sine 3x, v is 1 minus cos x. So by using the formula v, this is v u prime minus u v prime over v squared. This is k1, and then another 2 marks, k1 here. When you solve, when you differentiate, you find u prime and v prime. Okay, so here you differentiate sine 3x, you will get cos 3x times 3 because of the constant 3 in front x here. Okay, and then minus with 1 minus cos 3x, and then minus, so here you differentiate 1, you get 0, differentiate cos, you will get sine 3x. So since you will get positive, differentiate negative cos 3x, you will get positive sine 3x. So multiply, you get negative 3 sine square 3x here. Denominator just leave as it is, and then here you can expand this fraction and this bracket. So 3 cos 3x minus 3 cos square 3x minus 3 sine square 3x. Right, so from here, as you can see, we have cos square plus sine square. Okay, even though the angle is 3x, okay, it doesn't matter. Okay, the most important thing is you notice that actually we are using the trigonometric identity here. Okay, cos square x plus sine square x equals to 1. So here 3 cos 3x minus 3. Okay, actually this is 1. Okay, k1 by using the trigonometric function, and then lastly, okay, denominator is 1 minus cos 3x. So you can factor out these things, the numerator, factor out negative 3, you will get 1 minus cos 3x. Okay, over 1 minus cos 3x squared. Okay, so you can simplify this one. You are left with negative 3 over 1 minus cos 3x. So that is your G1. Okay, so that is the answer. for question 1A through Roman. Alright. And then we look at question 1B. Okay, they give you t equals to ln 3 over s and r is 2 over 5 sine t. They want you to show that the r over the s is equivalent to negative 2 over 5s cos ln 3 over s. Okay, so this is your t, this is your r. They want you to find the r over ds. So this is t in terms of s, this is r in terms of t. So how do we do it? Okay, so r equals to 2 over 5 sine t, t equals to ln 3 over s. So first we change this by using law of logarithm. Okay, so you have ln 3 minus ln s. So differentiate r, dr over dt, you will get 2 over 5 cos t. Differentiate dt over ds, you get negative 1 over s. Since this is a constant, differentiate constant, you get 0. Okay, so differentiate negative ln s, you get negative 1 over s. Now, to get dr over ds, okay, so you need to multiply dr over dt, multiply with dt over ds. So you will get dr over ds over here. So just multiply these two functions, 2 over 5 cos t minus negative 1 over s. Okay, so here you will have negative 2 over 5 s, okay, cos t here, this is t, so t here is ln 3 over s, so just substitute. Okay, so your first 2 marks is whereby you find dr dt and dt ds, and then k1 you substitute into the formula, and then final answer you shown. Okay, so that is 1b. Next, question 2. If y is equals to e power of negative 2x ln x plus 1, show that this function is equivalent to 0. So first thing first, you need to find your first derivative and your second derivative. So this is your function. Okay, you have two functions that are multiplied together. So u dot v. So you need to use product rule. Okay, product rule is u v prime plus v u prime. Okay, this is k1 g1, the first 2 marks, and then you differentiate ln x plus 1, you get 1 over x plus 1, and then you differentiate e power of negative 2x, copy back your exponential function e power of negative 2x, multiply with differentiate power. Differentiate your power here, negative 2x, you get negative 2. So negative 2 e power of negative 2x ln x plus 1. This is k1. And then you simplify the answer here, because this one you have e power negative 2x, this is also you have e power negative 2x. Factor out, you get 1 over x plus 1 minus 2 ln x plus 1. This is g1. Okay, find the second derivative. To find second derivative, use your first derivative and differentiate again, okay, to get the second derivative. So same thing as before, this is u dot v using product rule. So u v prime plus v u prime. Okay, so k1 g1, and then you differentiate this function. 1 over x plus 1, you get negative 1 over x plus 1 square minus 2. Differentiate ln x plus 1, you get 1 over x plus 1 here. Okay, and then this v you just copy back. Okay, this is the value v. U prime, differentiate, you get negative 2 e power negative 2x. So this is your k1. And final answer, you just multiply everything inside the bracket. So here you get negative e power negative 2x over x plus 1 square minus 2 times e power of negative 2x over x plus 1 plus, this is they already simplified, so you need to expand this thing. Okay, so you will get this answer G1. Alright? Okay, now to show that left hand side equals to right hand side, so this is your left hand side. Left hand side equals to this function. So just substitute x plus 1 square, copy back. D square y dx square is this function over here. Okay, this is the function that you already find above. Okay, plus with 2 times dy dx. So 2 times 2. This is your dy dx. So 2 times dy dx plus 2x plus 3 times e power negative 2. So you multiply the value, substitute the value inside the left hand side, you get k1 and then another k1. You simplify and then another k1. Okay, you multiply the value inside the bracket and then you get your answer j1 should 0. Okay, so that's it for question 2, section B.
For question number 3, you need to evaluate the following integral. For 3a, you need to you have a function divide another function. So you cannot integrate directly. So what you can do, you can rewrite the expression. So you can choose to transform the single fraction into sum of two fractions. So here you have two terms and you can simplify. So to simplify indices, since numerator and the denominator you have same base, so the power you can subtract. So that's why you will get 3x plus 3. Okay, so for the second term, you can bring the numerator as the denominator as the numerator, but you need to change the sign, so the power become negative. Okay, then after you get this form, then you can integrate separately. You can integrate e power of 3x plus 3 and then you will get e power of 3x plus 3 over 3. You need to remember to divide with the coefficient of x. And then here you need to divide with the coefficient of x, which is negative 2. So negative become positive. Okay, then don't forget to plus c. Okay, then you will get 3 marks for this question. For 3b, okay, same here, you have a function divide another function. So you cannot integrate directly. So you need to change the expression. You can rewrite the expression from single fraction. You can transform into 3 fractions, into 3 terms. So then you simplify. So 1 over cos square is equal to secant square. Okay, then after you have this form, then you can integrate separately. So integrate secant square, you will get tangent, and so on. And then so because you have upper and lower limit, so you need to substitute the upper limit and then minus with the substitute the lower limit. Okay, then you will get the final answer. So for this question, you will get 4 marks. Now for question number 4, you need to use substitution to solve the definite integral. Okay, so first you need to differentiate Q with respect to P, and then you rearrange so that dP become the subject. Okay, next we will substitute the original question with in terms of Q. So P square will be Q. P square is equal to Q, and dP is equal to dQ over 2P. Okay, next we simplify. So P will cancel with P here, and then to integrate you need to expand first. So you expand the EQ. Okay, then after that you can integrate separately because you have a function plus another function, and then the expression is in terms of Q only. Okay, so we integrate 3e power of Q, you will get 3e power of Q. And e power of 2Q need to divide with the coefficient of Q, which is 2. And then plus C for indefinite integral. Okay, since the function the integral here you have lower and upper limit, so you can proceed with substitute the upper limit into the expression, and then minus with the lower limit, and then you will get the final answer. So since the question asks you to find the exact value, so that's why you need to give your final answer in terms of E instead of decimal. Question number 5. You are given a function and then you need to use integration by part to show the following statement. And then B, you need to find the definite integral. Okay, there. So to use integration by part, you need to choose U and dV. So to choose U, you can use Lopet. So from your function, we have x. So x is polynomial. And e power of 3x is exponent. Okay, so according to the Lopet ranking, polynomial is higher than the exponential function. So polynomial, which is x, will be better option to choose as u. So the exponent will be dv. Okay, then you differentiate u, and then dv you need to integrate. Okay, then you need to substitute into the formula of by part, which is uv minus integrate v du. Okay, then you need to continue integrate v du. Okay, then after you finish, you have done your integrate, then you need to substitute upper limit and minus with the lower limit. And then you need to know how to simplify exponent so that your answer will be the same as the right hand side. Okay, next B, you can substitute fx into the function, so you will get a new function, and then you can proceed with integration by part by choosing u according to the Lopet. So x squared is polynomial, so polynomial will be is chosen as u. and e power of 3x as dv. So you need to differentiate, dv you need to integrate, and then substitute into the formula of by part, and then you need to solve the integral of v du. So you will get this, and then okay. So for integral of x e power of 3x, if you compare with your function, with your question A, so the expression is same with 5a. So you can use your answer from previous question, and then you substitute into the integral. So after that, you need to simplify the exponent. You need to know how to simplify the exponent so that you will get the exact value. So your exact value must, if you have exponent, you need to give your final answer in terms of exponent instead of decimal. Question number 6. A, you need to find the integral of the function. So to solve the integral of the given function, you can integrate directly. So you will get the final function. For the second question, you need to find the area bounded by the curve. So the curve here is the curve for px, and then bounded by the x-axis. So x-axis, and then lines x equal to 1 and x equal to 4. So this is your area to be you need to find. Alright, so formula area is you need to integrate the lower until upper limit. So your lower limit is 1 until 4. Upper function minus with the lower function. So in this case, your upper function is actually the curve. The curve. So the curve fx. And your lower function, so your lower function is here, which is your x-axis. So for x-axis, meaning that y equal to 0. For the upper function, your y is equal to fx. Fx is 10x plus 3x square minus x square. Okay, so since upper minus with lower, so you will get this expression for area, to find the area. Okay, then you integrate since the function is the same with the previous question. So you can use your answer from the previous question, and then you need to substitute the upper limit and then minus with substitute with the lower limit. Okay, then you calculate the value. Okay, next for question C, you need to find the area bounded by the curve and the straight line PQ. So to find the area, your lower limit is, so the area for C is actually the area from the curve and the line PQ. So that is the area you need to find. So so the limit is still 1 until 4, and the upper function is actually the curve. Okay, the lower function will be the line PQ. So that's why your formula to find the area is the curve minus with the straight line. Okay, then you can integrate. You can use your answer from the previous question because the function is the same. And then for x plus 8, you need to integrate, and then you substitute with the upper and minus with the lower limit. And then you will get the final answer. Question 7. You need to find the area of S, which is bounded by the curve ln y equal to ln x axis, line x equal to 1 and x equal to 3. So if you sketch the graph of ln, this is the basic shape or basic graph for log or ln. Okay, so it will intercept x-axis at 1, and then you have asymptote at x equal to 0. Okay, then you can identify the area. So bounded by x1 and x3 and bounded by x-axis. So here is the area you need to find. Okay, so to use the formula for area, you need to integrate the lower until upper limit. So lower limit is 1, upper limit is 3. And then upper function minus with the lower function. So from x1 until 3, your upper function is the curve, which is y equal to ln x. And your lower function, lower function is actually the x-axis. So x-axis is y equal to 0. So that's why to find the area is actually integrate 1 until 3 ln x minus 0 dx. So you will get formula for area for the following area. Okay, then to integrate ln, you need to use by part. So integration by part, you need to choose u and dv. So to choose u, you need to use loped. Okay, so since you only have log, so u is your function log will be chosen as u, and then dv is actually your dx. Okay, then you need to differentiate u. So differentiate u with respect to x. You will get 1 over x. And you need to integrate dv. So you will get v, and integrate dx, you will get x. And then you substitute into the formula. So formula for integration by part is uv minus integrate v du. Okay, then simplify, and then you need to integrate 1, so you will get x. And then you need to substitute the upper limit minus with the lower limit, and then you get the final answer. Okay, next B, you need to find the volume. The volume of the solid generated with rotated through pi radians about the x-axis. Okay, so from the graph of ln x, you need to rotate the area for pi radians. So pi radians meaning 180 degree. So your volume, your rotation is not a complete rotation. So it's not 360 degree. Your rotation is only 180 degree. So based on the formula of volume, instead of pi, you need to choose pi over 2 because the rotation, because of the rotation is not a complete rotation, not a 360 degree rotation. So you need to the rotation only half of the complete, so that's why you need to half. You need to divide pi with 2. Okay, then so the formula is you need to the function, the outer function, outer function square and minus with the inner function. So your outer function is actually your ln, your function ln, and your inner function is actually your x-axis. So y equal to 0. So that's why you will get the formula to find the volume is ln x power of 2. Okay, then so for this function, this kind of function, you can use integration by part. So you can choose ln x power of 2 as u, and then your dv is dx, and then you differentiate u, and you integrate dv, and then you substitute into the formula of by part uv minus integrate v du. Okay, then you integrate ln x. So for integrate ln x, limit from 1 until 3, you can compare with your previous question, which is that is actually the area. So you can use the answer for the area to substitute into the next step, and then you substitute the upper limit 3 minus with the lower limit 1, and then you calculate the answer, and then remember to put the unit as unit cube. So that's all from me. Thank you.